So here we have standard form of an equation, and we still need to be able to graph this equation or find its vertex and find things about it. So one way to change an equation from standard form into vertex form, and remember vertex form, the form that we want, is going to be f of x is equal to a times parentheses x minus h squared plus k, because that form, vertex form, gives us hk, the vertex of the equation, and makes it easy to graph. Okay, so when we're looking at this though, we can see that it's actually in standard form. So there's a technique called completing the square, and it is a factoring technique. So if you've heard of it before, you may have done it in this context, or you may have done it in other factoring contexts before, but we're going to review it here or learn it here. So the first thing that we want to do is alter our equation a little bit, just move things a little bit. So we're going to put in parentheses x squared plus 8x, the first two terms, and then we're going to put a little space to be adding something else into the equation. And then we're going to continue and have the plus 2 outside the grouping symbol, outside the parentheses. And then because we're adding something to the equation, we're going to add a number to the equation, we're going to have to subtract that number over here, okay, in order to keep our equation balanced. So in this parentheses, the number that we're going to add is a special number that's going to make this parentheses factor perfectly, okay? And the factoring that we want to get to is x plus 4 squared. Okay, this is a perfect square factoring. And so what we're doing is creating this perfect square factoring. So x plus 4 squared, I got the 4 from taking half of this 8. Okay, and how we would get x plus 4 squared, right? Think about it. If you FOILed x plus 4 squared out, right? If you multiplied it out, I'm going to do this and then erase it away, okay? I would have x plus 4 times x plus 4, right? My first term of the FOIL would be x squared. Then I would have plus 4x plus 4x for the outer and the inner, and the last term would be 16. That's that number we don't have because look, x squared plus 8x is from the original equation. We just don't have this 16. We don't have the right constant added on. So completing the square is adding in the correct constant to the equation. So this here is 16, because then 4 times 4 is 16, and it's a perfect square factor. Okay, the only way that we are allowed to do this to equations is because we're adding 16, so therefore we subtract 16. Okay, therefore we didn't change the equation at all. So let's complete this other part out here. So we have plus 2, and then we were subtracting 16. And then in the next line, we can see that we have factored this as x plus 4 squared, and then we have plus 2 minus 16. So that is a total of minus 14 in the constants. Okay, like I said, I'm actually going to erase this, because that's just thought work. We don't need to actually use it. Okay, but now notice if we put that f of x back over here, this is in vertex form. Okay, this equation is now in vertex form. The vertex is h comma k, right? But it's actually, minus the h and plus the k. So the vertex of our parabola is the opposite of the x term, minus 4, and the regular of the y term. So the vertex is negative 4 comma negative 14. If we had to graph this, we would also notice that the a, the vertical stretch, there's no number there, so the a is 1. So we would just be doing some shifting for this equation. Let's do another example so you can start to see the pattern of completing the square. So here we have f of x is equal to x squared plus 4x plus 2. Okay. So we're going to rewrite our equation using parentheses, x squared plus 4x, and then we're going to leave a little space for a number, and then plus 2, and then we're going to subtract whatever that number is out here. Okay, so for this equation, the completed square that we want to get to is x plus 2 squared. It's always going to be half the middle term's number, okay? So I just took the 4 from the x term and divided by 2. Then if you think about foiling this out, right, it would be x squared plus 2x, and the last term that we need is 4. Okay, and I get that by taking this number here, this half the middle term, and then I square it. I multiply it by itself, so 2 times 2, 4. All right, so then if we're adding 4 in the parentheses, we need to subtract 4 outside the parentheses, so that's minus 4 there. So down here we have plus 2 minus 4, so this would be minus 2. Okay, this is in vertex form, so now we can see that the vertex is negative 2 comma negative 2. Okay, please notice that it's x minus h squared, so it's always the opposite of the x term, and then it's just plus k, so it's just always the same as the y term. That comes from the transformations. Remember how in x we always undid things. All right, let's do another example where notice in this case the a was still 1. So we should do an example where the a is not 1 because that does actually make our algebra, we have to do a little bit more algebra with it. Okay, so for example, let's see. Oh, perfect. F of x is equal to 2x squared plus 8x plus 5. Okay, so the only difference, this is still in standard form, but notice that the a value is 2. Okay, so in order to complete the square, the first thing we're going to need to do is get that 2 out of our parentheses. So we don't want the 2 in the parentheses that we're completing. So we're going to divide this first term by 2 and just get x squared. We're going to divide the second term, 8x, by 2 and get 4x. And then we're going to still leave a little blank for adding something to the equation. And then here we're going to add the 5 outside the parentheses. Notice we don't need to divide the 5 by 2 because it is not involved in this parentheses thing. Okay, and then remember we're going to subtract whatever we put, whatever we added in the first place. Okay, so we still complete the square the same way inside the parentheses. So x squared plus 4x. Okay, try to see if you can come up with the number that would go here. Any ideas? Okay. That number should be a 4. Okay, because you're taking, in the next step, you would have x plus half that middle term, 2 squared would be your completed square, right? And so half that middle term, and then the last term would be 2 times 2, or 2 squared, which is 4. All right, so here we have 5, and then minus. You might think we are supposed to subtract 4 here, and that would be wrong, okay? That would be wrong because look, we did not actually add 4 to the equation this time. We technically, because of this parentheses, we added 2 times 4, 8. Okay, so in other words, we have to now subtract 8 from the equation. Okay, so just keep that in mind. That's the only difference when there is an a value that is greater than 1. Okay, so now we still have, let's see, plus 5 minus 8. So that's minus 3. And then we can just write, hey, there's our vertex form. Okay, so we can see our vertex is h comma k. So that is negative 2 comma negative 3. And our a value, our vertical stretch, is 2. Okay, so that will enable us to graph the equation.